This is 4.7, number 43, L'Hopital's rule. And since it's L'Hopital's, I'm assuming it's going to be L'Hopital's, so I'm going to go right to the limits. The limit as x goes to infinity of x squared minus ln of 2 over x. All right. Clearly, that's infinity squared. But what is this? So let's talk about that. ln of 2 over x. 2 over infinity is 0. What's the ln of 0? What is the ln of 0? Okay, as a review, let's remember what the ln function looks like. Like that. And so as x goes to infinity, 2 over infinity approaches 0, but it's always positive. So you're approaching 0 from positive numbers. Well, I'm going to approach 0 from positive numbers. What does the y value approach? Negative infinity down here. So this is going to be infinity squared minus negative infinity. Well, that becomes plus infinity. Infinity squared plus infinity, clearly that's infinity. And the bottom, three infinity squared plus infinity, again, that's clearly infinity. Infinity over infinity. Therefore, L'Hopital's theorem applies. Therefore, I can take the derivative of the top and the bottom, right? So we can say this equals the limit as x goes to infinity. The derivative of x squared, that's easy, 2x. Minus, this is ln of box. What's the derivative of ln of box? Well, that's going to be 1 over box, and I'll go ahead and write like that, times the derivative of box. But what's the derivative of the box? That's going to be negative 2x to the negative 2. So once again, this is box. ln of box is 1 over box times the derivative of that, which will be that. And we will have to deal with that portion. Now we take the derivative of the bottom, which is 6x plus 2. And we are going to do some simplifying on the top to make our life easier. So that minus and that minus is going to make a plus. I can handle that. Dividing by 2 over x is like multiplying by x over 2. So I'm going to rewrite that as x over 2. So this negative x squared is going to become positive x squared when we move it to the bottom. And then one of those x's is going to cancel with one of those x's. That 2 is going to cancel with that 2. And I'm left with 1 over x. Is that right? Could that be? I think it is. That's kind of beautiful. Okay, let's take this limit again. The limit as x approaches infinity of the top. Well, 1 over infinity, that's 0. 2 times infinity is infinity plus 0, that's infinity. And the limit of the bottom is infinity again. So therefore, L'Hopital's theorem applies again. Therefore, this equals the limit of the derivative of the top, which is 2. And again, this is x to the negative 1 power. So it's going to be minus x to the negative 2 power over 6, which is, let me rewrite this, 2 minus 1 over x squared over 6. As x goes to infinity, that's 0. So we get 2 over 6, or 1/3. So the answer to that long problem, 43, is 1/3.